Today in pre-calc we learned about rational functions, and this is going to be about a 2-week long unit that we're going to do. Today we want to look at some of the information about the parent functions, how to do the transformations, and then how to find the domain. So for part A for today, we're going to talk about the parent function. Which is f of x equals 1 over x. And when we covered parent functions at the beginning of the year, we did not include this one, so that's why we're going to go back and go over it now. Its domain, normally, for the parent function, is from negative infinity to 0, and from 0 to infinity. Its range is from negative infinity to 0, and from 0 to infinity. And it has asymptotes at x equals 0 and y equals 0. So if we see what that graph looks like, we're going to draw our x and y axis. We are going to draw some asymptotes on top of the x and y axis because that's where y equals 0 and x equals 0. I drew them a little bit to the side so that you'd be able to see them, otherwise you would not be able to, and that would be a problem. Change controls and add a slide here. And then the graph just hugs these curves. So one here and one here. It gets real close but does not touch. Which brings me to the next point, the definition of an asymptote is a straight line which a curve approaches but never touches. And the reason that that's important is because we're going to use these asymptotes to do our transformations. This is a general definition of an asymptote. Eventually we might have some that cross and that are not straight lines but curves, so we'll get into that more later. For now, this is the definition that I want you to think of when you think of asymptotes. Those are just these imaginary dotted lines that the graph never touches. Okay? Part B for today was about transformations. And I'm sorry, I'm really having pencil problems. We'll try a pen. Okay, part B, transformations. You'll need to remember your rules from earlier in the year when we learned about transformations of any function. But now we're going to be talking about transformations of just these rational functions. Okay, for example, number 1, if I have f of x equals 1 over x plus 2. The plus 2 inside of the parentheses, or with the argument, however you want to say that, tells me that I shift left by 2. So I'm going to draw my graph. I'm going to draw my regular horizontal asymptote. On my vertical asymptote, I'm going to go left 2 and move that asymptote over 2. So I'm moving the whole graph over by 2. And those asymptotes guide me to where my graph will go and what it will look like. So that's my graph of my transformation. Let's look at a few more. If I have f of x equals negative 1 over x. Remember, a negative just means it's a reflection. And in this case, it doesn't matter if it's reflected over the x or the y because the same thing will happen regardless. So I'm going to leave my asymptotes. And what would normally be here will now be over here in the second quadrant. And what would normally be here will be over here in the fourth quadrant. And that is how that one is reflected. Let's do one more transformation. F of x equals 1 over x plus 2. Notice the 2 is on the outside this time, which tells me that this function is shifted up by 2. If I draw my graph, my vertical asymptote stays the same. My horizontal asymptote moves this time to shift up by 2. And my graph follows the normal pattern, just close to those asymptotes. The last thing we need to talk about today, part C, is how to find the domain of a rational function. And this is something we've actually covered before, just not in relation to rational functions. And the question you should be asking is, what makes the denominator equal 0? If you're not sure what makes the denominator equal 0, you may need to factor it to be able to figure out what that is. Wherever the bottom equals 0, that's what we are going to throw out of our domain, because remember, 0 in the bottom of a fraction means that something is undefined. So example number 4, let's look at some like this. F of x equals 3x over x minus 1. We don't care what the top says. We're not dealing with that just yet. Another day we will. But for now, we set the bottom equal to 0, so x minus 1 equals 0. I add 1 to both sides, and x equals 1. So my domain is where x does not equal 1. We had quite a discussion in class today about this and what the domain is versus what it isn't. In this case, it's going to be easier to write what it is not. X is not equal to 1, so every other x will work, than it will be to write negative infinity to 1 and 1 to infinity. Although this would also be correct, this is the form we're going to write them in for this section. We're going to say, what is the domain not equal to? Example number 5, f of x is equal to x squared plus x minus 2, all over x squared minus x minus 6. We don't care about the top. Again, we're going to factor the bottom, x squared minus x minus 6, which can be factored fairly easily into x minus 3 and x plus 2. If I solve those, I'll get x equals 3 and x equals negative 2. So my domain is x does not equal negative 2 and x does not equal positive 3. And I'll want to write those in order from least to greatest. That will be particularly helpful when we start graphing later on in this unit. Let's look at one more example so we can practice factoring things that are a little bit more difficult. This one is f of x equals x squared minus x minus 6 over 2x squared plus 7x minus 4. If I take that bottom, 2x squared plus 7x minus 4, and I factor it, I'm going to use my father drives a red Mustang. I'm going to multiply a times c. 2 times negative 4 is negative 8. I'm going to figure out what multiplies together to get 7. In this case, it'd be negative 1 times 8 gives me 7. I'm going to divide by my a, which is 2. I'm going to reduce my factors. 1 over 2 cannot be reduced. 8 over 2 can be reduced to 4 over 1. I'm going to make my multiples by putting x on the bottom, and I'm going to read from the bottom up. So my factored form is 2x minus 1 times x plus 4 equal to 0. When I solve both of those, 2x minus 1 equals 0 and x plus 4 equals 0. I'm going to add 1 to both sides. 2x equals 1. X equals 1 half. And on this one, I'm going to subtract 4 from both sides, and x equals negative 4. So my domain is that x does not equal negative 4 and x does not equal 1 half. Your homework is a worksheet today. It's A12. It is very similar to this homework. The first 4 problems are like B, and the last set is like part C. Please be sure to get some practice immediately on this work so that later on this week when we move on, it will be easy for you to do that. Let me know if you have questions.